Monica, are you
Okay,
here?
hello. Yes, I'm here. Do you hear me?
Yes,
Yes.
Monica, thank you.
Okay,
You can
good.
share your screen
Perfect.
with your presentation.
Yes, let me know if you see now my presentation.
Yes, yes, okay.
Okay, good. Okay, perfect. So, good morning, everyone. My name is Monica Agreda Lopez, and today I'm going to present myself and also the project where I'm going to work during this 3 years PhD program. So the title is Data-Driven Approach to Investigate Pre-Eruptive Magma Storage at Trigger Mechanism of Volcanic Eruption, and is under the supervision of Professor Mauricio Petrelli in the University of Perugia and also Luca Caricchi at the University of Geneva. So first, let's start to introduce a little bit about my background. I'm a geologist. I did my undergraduate studies at the Universidad Nacional de Colombia in Bogotá. This is a 5 years bachelor program. Then I moved to Switzerland, where I started a master's studies for 2 years between the Universities of Geneva and University of Lausanne. And it was there when I started to focus more on volcanoes. And now I'm starting the PhD at the University of Perugia. Now let's pass to talk about the project itself. So the main idea of this project is to develop new models that will help us to better understand the architecture and the evolution of volcanic plumbing systems. But how are we planning to do it? So we're going to focus mainly on machine learning techniques. But as machine learning is one of the main focus of our project, I consider important to clarify what machine learning is. So machine learning is a combination of techniques that uses computational resources to run algorithms that learn how to automatize, classify, and predict values, starting from an initial, generally large and complex dataset given by the user. This is really important for us in geology because with this tool, it helps us to highlight and uncover factors of patterns that occur in large and complex processes, when we have large and complex processes occurring at the same time in a non-linear fashion. That is the case as, for example, volcanic eruptions. Now, machine learning has like two main branches, that is the supervised learning and unsupervised learning. We're gonna use both of them in this project. In the branch of the supervised, we're gonna use focus on regression to obtain then thermometers and barometers for the data. And then in the unsupervised, we're gonna focus on one tool that is clustering, that is very useful to highlight hidden features in terms of, for example, textures, petrographic observations, chemistry. The idea is that we're going to work with major elements, trace elements, and isotopic records. For the major elements and trace elements, we're going to work with 1D profiles, compositional profiles, but also with compositional maps. And this leads us to some collaborations. First, with the University of Geneva, where we're going to use the electron probe microanalyzer to obtain major element data, and also with the National Institute of Chemistry in Ljubljana, Slovenia, where we're going to go to acquire compositional maps, trace element maps, with the laser ablation ICP-MS system they have. Then I put here some pictures just to illustrate the object of our study. So we're going to basically focus on acquiring data on magmatic crystals. In the left side here, you see an SEM image, an scanning electron microscope image of a clinopyroxene. So we're going to also work with classical methods and texture interpretations. And then we have here in the right side, two images taken from the paper of Ubide et al. 2015. In the left side, you have a clinopyroxene crystal, and in the right side, you have a compositional map, in this case from the chromium. And this is just to show with what we are going to work with, more or less, and the importance of this. In this case, you see, for example, the high chromium content here in this crystal that indicates an input of more mafic material that, of course, lead us to have an understanding of what's happening before the eruption in this particular case. Now we're going to try to apply all these to two main study cases that are the Colli Albani volcano and the Campifligre caldera. And with all this together, we're going to put all these conclusions and results in at least 3 publications in international journals, and also with participations in congresses, international congresses, as for example, the AU or the Goldschmidt. And that's it. Thank you very much for your attention. And if you have any questions or comments, please let me know.